let's say that this is a network in here, this is the router in the network, and this is one of the clients. For example, we are the client in here. There may be more clients in this network. This is the ISP or the internet service provider. As you see, the router has two interfaces. One of the interfaces is connected directly to the ISP or internet service provider, and the other is the clients are connected to the router. In this example, this client is connected to the router. It could connect via a wire or wirelessly. Now, we said that the ISP would assign a public IP address to the router. Let's say this public IP address is equal to 1.1.1.1. Also, the other network interface card of the router would have a private IP address that, let's say, we have assigned to it the address of 192.168.1.1 as our gateway. When this client wants to connect to the network, the router would act as a DHCP server. You might also have DHCP server separately, but in this example, the router would act as a DHCP server, assign an address of 192.168.1.44 for this example. Now, let's say that this client in here wants to send some data, some HTTP request to the washington.edu, which is the website of a university in the Washington. So what happens is that first the client that wants to send a request, in this example a browser for example, would ask the operating system that a port number. The operating system would assign a port number. Let's say it is in the ephemeral range. We talked in the previous lectures the range of the ephemeral port numbers. I think, yes, it is between this range. Let's say that for our example 50,000 is the port number that the operating system is assigning to this client. Now what it means is that right now a socket has been created. This socket would act as an endpoint representing the communication between the browser as a client and this web server in here. So 192.168.1.44 and the port number of 50,000 is a socket that has been created to make the communication. So in this example, this socket would send a packet to the router because the packet should go outside the internet, and this is a private IP address. It would go to the router would look at this packet, looking at the source and destination IP and port numbers, and it would write them inside a table. So it sees, for example, that the source IP address is 192.168.44, the port number of 50,000, this is a packet, the destination is 5.5.5.5. This packet are going to go to the port number of 80, which this web server, this washington.edu, is actually listening at this port now. So a listening socket would be created at the other side with this information, the IP of 5.5.5.5, listening to the port number of 80. So the router knows that this packet, this private IP address, is non-routable. So when it wants to forward the packet, it would translate the private IP address to its own public IP address. So 192.168.1.44 would be translated to 1.1.1.1, which is the public IP address the router got from the internet service provider. Also, the port number of the socket in the client is equal to 50,000. It might translate it to other kind of port or use the same number. So in this example, the router also uses the same port number, and it would write this data inside a table. So the router would forward this packet to, for example, the ISP. The ISP in the upstream router in the ISP would forward it. Every router would make a decision based on the destination IP address and different routing protocols or other things that are not the subject of this lecture, but somehow this packet would get to the destination. In here, a HTTP implementation like Apache, which is a web server application, is listening at the port number 80. It would receive the packet and somehow analyze it, parse it, and wants to send the related response. So in other ways, it comes to the internet service provider. The ISP would forward it back to the router. Now the packet has reached the destination. The destination IP address in the packet sent from the washington.edu would be 1.1.1.44. one with the port number of 50,000. So the router would look at this table, seeing that every packet with this address, with the destination IP address of this information, should go to this socket, because this socket has initiated the request and is listening at the port number of 50,000. So it would just translate this information back to the original information in the NAT table. You call it the network address translation or port address translation. Now it would forward them, so change this address to this address in here, send it to the client. As you see, the packet has reached the client and the socket is listening at this port number, so it would receive the information, and well, if it is acting on behalf of the browser would just translate the HTML code it received from the washington.edu. In the next lecture, we would see all of these things in the action in Wireshark.